In this presentation we're going to have a look at some basics around IP and MAC addresses and hopefully see how we can interconnect over the network, how these addresses are actually allocated. So normally in networks we try and abstract out the different parts of the communication, so we want to get data from one machine to another. So in order to keep compatibility with software and hardware and firmware, we often abstract it into different layers. Each layer has their own function, and each layer typically has a protocol which is associated with it, which is then standardized across all of the network. One of the first of these models was known as the OSI, Open Systems Interconnection 7-layer model. And with this, we abstract into 7 different layers. At the lowest layer, we have the physical layer, and that's really to do with the cables, the electrical signals, the pulses of light, and so on the line. Then above that, we have some mechanism for being able to take the data and to format it for to be transmitted over to on the local network. Later on in this module, and we'll look at Ethernet and see what a data link layer looks like. But a typical data link layer is Ethernet. And then at the network layer, we have the concept of a network address. And this provides us with a way to be able to send data over a network and for it to be delivered at a certain destination. So typical protocols that we have here are IP and IPX, but IP is one of the most significant here. Above that we have the transport layer, and it's up to the transport layer to make sure that all the data packets that we're going to be sending actually arrive and are reliably received, and where errors can actually be detected. So the typical protocols that are used here are TCP and UDP. Above that, we then get what are normally called the application layer protocols, and they cover application, presentation, and session. And it's really here that we get the concepts of things like FTP, Telnet, web, and so on. And often the protocols have been designed so that they cover all 3 of these layers together. So if we look at it, what will basically happen, and we'll cover this in more detail later on, is that we start off with our data, we take it through each of the layers, and then we transmit it across, and it goes back up through each of these layers to the other side. As we'll see later on, we can go through intermediate layers, such as with bridges and switches and so on, but really each of the layers is responsible for its own little bit. And on the other side, we have normally a piece of software or hardware which is responsible for looking after that little part. So now let's look at something a bit more real. We'll look at how a data packet can go from one computer to another. Okay, so here's our basic infrastructure. We're connecting onto a switch, and that switch eventually goes to a router. These routers all interconnect, and then we have a switch on the other end. So what we want to be able to do is for Bob to be able to communicate with Alice and use this whole infrastructure. So each computer on the internet has a physical address and also a network address. On the internet, these network addresses are used to route the data between these intermediate devices, where when we get to the very end of the network connection, this part in here, then it's the physical address along with the network address which is actually used to deliver the data. So the physical address is only actually required for the last part, the first part and the last part of the journey. As we'll see, when the data travels over the network, the physical address of the data packet as it travels, or the data frame, will actually change as it goes through the network. but the network addresses never change. So we have both a physical address and a network address. And if we just look on every computer, we could have multiple network addresses. So in this case, we can see here that for my wireless network, then my IP address or my network address is this one here. If I want to find out my physical address, as we'll find out a little bit later, I can use another command called ipconfig/all, and in this case I can now get more details of what my physical address is. And this should be a unique address on my network, and that is defined as what's called a MAC address, an immediate access code address, and this gives me my physical address for my machine. Each of these can be spoofed at any time, but it's easier to spoof the network address than it is to spoof the MAC address. But you should never take the physical address as a definite identification of a host. It's fairly easy for someone to change their MAC address to be someone else's MAC address. So let's say that Alice has just turned her computer on. So it would be probably very difficult for Bob to remember every single IP address that he connects to, and probably Alice has moved her computer or might have changed the network card. So normally we need an easy way to be able to find her, and we bring in the concept of a domain name. So domain name is an easy way for us to be able to connect to another device, such as a web server or so on. So in this case we now need what's called a name server to be able to map the domain name onto an IP address. So again, we'll cover this in a later unit, but we normally use Nslookup to be able to determine what the IP address is. So whenever we access a website such as cisco.com, our browser does a lookup, finds out what the IP address, and then uses that IP address to be able to connect with the remote device. Okay, so the name server is another key important principle that we have inside the internet. Okay, so that's provided us with a very basic introduction to the internet. Another key concept that we have is that we have the concept of what's called network address translation. So as we'll find out, the IP addresses can be mapped into a common infrastructure called the internet, and we give it a capital I for internet because it's a real thing. So these addresses are controlled and allocated. So if you want to connect to the internet, then you need a public address, and if you want to route between these intermediate devices, then they route with public addresses. It would be difficult for us to be able to get public addresses for all our computers that we might want to connect. The basic fact is that we've actually run out of IP addresses, IPv4 addresses, so there are no more to go around. So we need some way to be able to allocate host with an IP address. So we use what's called private addresses, and the advantage with a private address is that no one can really connect to us because we don't really have a public address unless we want to. So we create what are called private address spaces. So if you connect from home, there's a very good chance if you're connecting over a wireless network, you have a private address, and everyone is allocated an address inside your network, which is private, and then you have one device, typically your wireless router, that will be able to connect onto the internet and allocate a public address. So it's a very important principle, and often it's very difficult to see the information that happens behind this NAT because it's private. Many companies use it for security protection, and that they can hide who's accessing it because all that's seen from outside is a single IP address whenever they look at the logs. So let's have a look at how we can allocate these IP addresses, and obviously we want to make it as simple as possible for computers to join onto the internet. So here's a sample infrastructure. So we have these routers here, and these routers will route the data packets across the network in an optimal way. For each machine that connects, we have a network address, and we also have a physical address. So if Bob wants to send to Alice, he needs to find out the network address of her machine. And he does that normally by taking the domain name, finding out the IP address of the machine, and then the data packets that he sends each will have a destination IP address of Alice's machine. So sample IP address is something like this. We have 4 digits separated by a dot. And a physical address has 6 double hexadecimal characters representing the unique physical address within inside the network that we're connected. So with an IP address that connects to the internet, that must be unique across the whole of the internet. But if it's a private network, then it only has to be unique within inside the network that we're connecting. Same with physical addresses, then the physical address only has to be unique within inside our own network segment. Okay, so this shows an example of our network. So the first method that we can use is if we actually know what the IP address is of the machine, we can set it up with a static IP address. The 4 things we need is to allocate the IP address, and then allocate the subnet mask. And the subnet mask will come across in more detail later, but it defines which part is the host part, wherever there's a 255 here. This is the network segment that we're on, and then the last digit represents the actual unique host. Then the other thing we need is a default gateway, and the default gateway is the port that we send data to that will allow it to be sent across the internet. And this is normally the port that we connect to of the router, the first router. When we send data, we determine the default gateway, and as we'll see later in the module, then that allows us to be able to send data packets out. Without knowing this default gateway, we can't actually route our data packets onto the internet. The other thing we normally need is a DNS server, and this will allow us to be able to set up our DNS server to be able to resolve our domain names into IP addresses. So let's take an example. So this is a Windows machine, and we'll just set up our network. And here's our adapters. Okay, so at the present time I'm using this network connection, and we would normally go to the IPv4 settings. So what I'm going to do is I'm going to set up, so the network I'm connecting to is actually this network, and I'll give it an IP address, and I just happen to know that the default gateway is this, and I also happen to know that the DNS server is this. So DNS is obviously such an important service that if one was to fail, then we can have another one, so we can have an alternative one there. Okay, so I can set that up, and then hopefully, and we'll come across this this command in more detail. Okay, and there we go. So there's the setting that we've just set up here. There's a default gateway, and so on. So in this way we would normally set up our IP address to be statically allocated. And normally we must connect onto the same network as the default gateway, because a router is the thing that will actually route the data packets over. So we need to connect to the same network that that device is on. The other method that we can use is to be able to use a DHCP server. So with a DHCP server, when we boot onto the network, the DHCP server detects our machine, normally with its MAC address, and then is able to allocate all those details that we had before. So this can happen in a wireless network. So in a wireless network, the wireless router will actually have a DHCP server in it. So when we boot up, our machine asks the DHCP server for these network details, and then we get that sent to us. So in this case, we'd set up our machine so that it would obtain the IP address automatically. So let's try that again. So we go back to here, and in this case we'll just ask for that. Okay, so we just check, and then hopefully, so we can see it's been allocated there. So it will take an address which hasn't been allocated and give it to us on the same network, and you can actually see that this is our IP address here that we've been allocated. Okay, and the default gateway again will have been allocated too. Okay, so this is the method that most machines are set up, and provides some security onto the network, that you can either allocate a static IP address always to the same machine, or you could take it from a pool. The way we do it in Linux is to be able to use the ifconfig command. So in Linux we have a number of interfaces. So let's see if we can find our VM. It just takes a little minute to start up. Okay, so we use the ifconfig command. ifconfig gives us our details, and with Linux they are defined with such as this. This is for Ethernet. This is what's called a loopback address. So with ifconfig we can actually define the IP address from here. So let's just put it on the same network, and we can define our subnet mask here. Just make it the same as this one, and sometimes you get that, so we've got to run it as a super user. give it the password. And there we go, we've changed the IP address. This is what it's changed to. So because we're still on the same network, then we should still hopefully be able to communicate with the internet. You can see in this case, we'll go into this in more detail, but we're using private addresses here, and this is because we're running within a VM. The VM translates our private address into a public address. So let's just try to see if that's working. Okay, that works perfectly. And the other option that we can have is to use DH client Ethernet 0. So in this case, it will use DHCP and get from the DHCP server. We can make the Ethernet network go up and down if we want. So IF config Ethernet 0 down, and let's try that. Ethernet 0 down, and hopefully there you go. So you can see it's now disconnected. So now unfortunately offline. I'll make it go back up. This takes a little minute. It thinks we're using a wired network here. That's why we get an Ethernet port. And hopefully now when we connect, then we're back online. In order to set the default gateway, we use the root add gateway, default gateway, and then we put the IP address after it. So if we want to actually have a look to see what that is, we can look at what's called the routing table, and the routing table will actually give us what the default gateway is. So in this case, here is our default gateway, and it's already been set up. So there's for the when we booted the VM, it would have asked the DHCP server, which is with inside VMware Workstation, and it's obviously been allocated to this address here. Okay. So that's the main details that we have with inside there. We can set up name server with inside with the name server command, and we can have a look at the resolve.conf. And the resolve.conf is the place that actually keeps our name server value. Okay, so those are the main commands that we would use in Linux to be able to set up the IP address, gateway, and so on. Now we'll look at two key commands that we have for Windows, is ipconfig and nslookup, and we'll find these are useful debug tools that we can use to be able to find out IP addresses, MAC addresses, and so on. So within Windows we have a command called ipconfig, and ipconfig gives us the basic details of our network connection, such as the IPv4 address, default gateway, subnet mask, and so on. And as we've just seen, ifconfig is used in Linux, and we can see here there's the IP address, there's the subnet mask. It gives us the status of it. We can see it's up just now, and so on. So those are the two basic commands. So let's quickly look at ipconfig. So ipconfig gives us all our interfaces. So you can see here we've got quite a few interfaces that are used. These are actually software interfaces, but we can usually look and find where our main interface is. So in this case, this is my wireless connection here, which I'm using to connect to the internet. You see a private address, there's my default gateway, and there's the subnet mask. And here's my name for the machine, which will be appended on to the DNS domain. And then if we look at Linux, as we've just seen, we can use ifconfig. So ifconfig gives us the IP address, subnet mask, whether it's up, and as we've just seen, we can make it go down. Just takes a little minute, and we should be able to see that it doesn't exist anymore. So we'll make it go up. And there it's back. Okay, so that's the two main commands that we can use to be able to determine some basic IP details. But if we want much more details, such as the MAC address, we've got to use ipconfig/all. So you can see here a key thing is that we can identify the MAC address of the device. IP addresses are given for a certain amount of time before the timeout. So we can see here that this is now valid. I obtained this address just before 10 o'clock, and it expires the next day at 7 o'clock in the evening. It's got my default gateway, my DNS, and so on. A bit more description about the network card, and so on. So let's have a look at that. So this time we'll use /all, and we'll look at the details here. So here's a wireless. You can see it's now got some more details on it, and there's the MAC address of the card. DHCP is enabled, so I got this from the DHCP server on the wireless device. And there's my lease. Okay, so that my IP address is granted for that amount of time. After that time, if I'm still connected, then I've got to renew my lease. A key concept inside the internet is the domain name structure. So with this we have a root of the internet, and then we have sub domains of that: org, gov, com, UK, DE, and so on. And then below that we map, in this case, company names, so of IBM.com and so on. And what happens is that each organization is responsible for their own domain name, or all the machines within inside their domain. And we have a record such as this, and this is the record that a company would keep to define how long their address is valid for, and each of the machines that are within inside their domain that can be accessed from DNS. So in this case, and we'll go into this in more detail later in the module, We have the main domain name, and below that we can have a mail server name. That's going to be our mail server, and then we can define the IP address of our domain, or the main node in our domain. In this case, this domain here has this IP address, and then from within there we can actually define each of the hosts that map on to that domain. So in this case, Fred, this machine here, is mapping onto 10.0.0.2, and so on. Okay, so this is an important record that a company will have, and we'll look in more detail at what that record entails. What we can do is we can use Nslookup to be able to interrogate parts of that record. So with Nslookup, we just run it, and then we use set SOA, and that will give us, we then enter the domain name that we are interested in, and it'll give us the details of that domain, as we've seen. The MX record allows us to be able to see the mail record. In this case, it will define the default mail servers. The lower the value, the higher the preference for the email server. Okay, so let's have a look at Nslookup. So Nslookup on its own will provide us with the IP address for the domain, but we can look at it in more detail. And we set type equals SOA, and then we'll look at Microsoft.com, and we can see it gives us more detail about the primary name server, secondary, and these other details. We can also set up for our mail server, and then it gives us details such as this. Same again, we can use Nslookup with inside our Linux image, and it should hopefully give us the same records. Okay. From a security point of view, this is a very important record, and we obviously need to watch if intruders are able to get hold of this record, okay, because they can take over a domain. So that has given us an overview of Nslookup. The other place that we can look for domain information is the Whois, and the Whois contains a record of domains that have been registered in different regions of the world. So the main US one is ICANN, but we can then look at other regions of the world to be able to get those registration details. So in this case, we can see there's Cisco, and it tells us who it's registered to, what the registered address is, when they registered the domain, contact, and so on. So let's have a look at what that will look like. We'll just bring up a browser. Go to IP and then Whois. So let's look at Cisco.com. So the return back is an IP address, and we can actually see the details here for the registered domain. When it was initially created, when it's going to expire and when it was last updated. It will also give us the name servers and who is the registrar for the domain. Okay, so you can try it different companies and actually have a look to see the domain name registration. Okay, so this is another place that we can actually find information about the domain. Whenever a domain is registered, it should have some details associated with it. We see even it has a telephone number here for the main contact and an email address. Okay, so this has provided us with an introduction to IP and MAC addresses.